Start recording is
I
right
got it.
next to where and start broadcast at the top.
Oh, got it.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to the PASS Database Administration Virtual Chapter Meeting. Today we're having a lecture on SQL Server Statistics and the new Cardinality Estimator. Susantha Bathagay will be giving the presentation today. My name is Julie Bloomquist and I'm going to moderate. We are sponsored by the Hewlett-Packard Enterprise. This meeting is being recorded. It will be uploaded to the DBA Virtual Chapter archive page. We really want to thank our sponsor. This affords us the opportunity to have raffle drawings with those who have attended. 24 hours of PASS, well, that's PASS. That was May 3rd and 4th. But they probably do have the recordings on the PASS website.
Julie, you're not advancing your slides. Just push page down.
That's what I did. Do you see the...
I'm only seeing the cover page.
So it's not changing at all? Because I
No.
showed... Okay, hold on. How about now?
There you go.
Okay. Once again, we want to thank the sponsor. Let me get back. There is a one-day business analytics conference on June 21st over in Atlanta. It's passbaday.com. You could register and it's only $5.95. The PASS Community Summit is coming up. It's October 31st to November 3rd. And if you use the code VC15FPS6, you'll receive a $150 savings when you register. There are quite a few virtual chapters with PASS, and you can associate your PASS login with any of these, and you will receive the emails about the meetings. All virtual chapters do record their meetings and post them on their archive page. SQL Saturdays are one-day mini conferences. These are the upcoming SQL Saturdays around the world. They have nominal fees, usually just to cover the lunch. You can join a physical chapter or you can join the virtual chapters. There are also many volunteering opportunities with PASS, and you can look at the PASS website and go to my volunteering section on your My PASS profile. If you did discover us on YouTube, we really would like you to become a member of the SQLpass.org. If you can join and then associate your login with the virtual chapter, that would be great. The PASS membership is free. And here, let me move this out of the way. So, Susantha is a Microsoft certified database professional specializing in its relational database products, Microsoft SQL Server. He has more than 16 years of IT experience, including more than 10 years in the database development and administration in non-production and production environments. He specializes in query optimization, T-SQL, administration and troubleshooting, and replication. He also writes for the popular SQL Server sites, the MS SQL Tips, SQLServerPerformance.com, and SQL Server Central. And I'm going to pass the presentation over to you. There you go, Sudhantha. And I see your slide deck.
Okay. So you see which
I see your the slide deck cover page.
page. Okay, perfect.
And we will be
Okay,
having
let's
questions at the end of the meeting.
okay. Right, let's start with our presentation. So these are the topics that we are going to recap. So in introduction, so what are the issues that we have seen with execution plans? So I'm sure we might have seen issues like query timeout, inconsistent performance of stored procedures, high TMD utilization sometime, or high CPU utilization, and overutilized memory. So as DBAs, we are experiencing these issues as almost daily basis, right, up to some degree. So some solutions you might have tried are like query rewrite, which makes sometimes a huge difference. Or recompilation is not always a bad idea. Sometimes it's a very good thing to do at the very beginning. So if you consider execution plan, it looks like the one in the presentation. So it has the operators, the logic flows from left to right, and the data flows from right to left. And you can see the access methods to access the data from storage in your right side of the execution plan, such as index seek, clustered index seek, lookup, things like that. And some concepts we need to understand before we go into detail, like a predicate. What is a predicate? It's a condition which can evaluate to true, false, or unknown state. So density. Density is another concept. It actually gives you an idea of how much unique value of a column has. So for example, in this, I have given a 2 columns table. One has ID and the other one is column 1. And the ID column density is 0.25. That is 1 divided by number of distinct values. So the other one has some duplicates, 2 distinct values, 1 divided by 2.5. The density of column 1 is 2.5. So if the density is close to 0, that means you have more unique values, and otherwise if it is close to 1, you have more duplicate values. So estimates, cardinality estimation, estimate a number of records written by a predicate. It could be where, close, having, join, group by operations, something like that. And selectivity is another thing we need to understand. It's a concept similar to cardinality estimation. So it actually the percentage of rows that satisfy by a predicate. Highly selective predicate returns small number of records, which is good. So understanding density, if the density is close to 0, you have highly selective predicates, returns less number of records, more unique values, which is good scenario. And if it is close to 1, density is higher, the low selectivity, it returns high number of records and also less unique values. And if we talk about or remind about the query execution stages, it has several stages. Today we are focusing on optimization stage, which actually evaluate different possible plans, and it uses statistics to evaluate different plans, and the output of that stage would be execution plan. So execution plan could be two kinds. It could be optimal or non-optimal. If it is optimal, you will get fast execution of queries. It consumes less resources. And if it is non-optimal, that is where the problem. So we get slow execution of queries and resource consumption is high. So let's come into statistics. It's a type of object exists in the database. It used to generate the execution plan can be associated with index, or they can exist on its own attached to a table column. And you can create manually, or Query Optimizer will create it for you during the optimization stage. It has three main pieces, and these are the three main pieces of the statistics object. First is the header. Second is the density vector, which has the density value that I explained earlier. And the histogram, the most important part of the statistic object. So Cardinality Estimator is a component within Query Optimizer. It uses the statistics as the input and then decide the estimated row counts for each and every operation in the execution plan, and then create the execution plan. So estimates and actual, you might have heard of estimates, and also we have seen actuals. What are actuals? Actual figures you will get after executing the query with the result set. But before executing the query, you will get the estimates, which is the figures that is used to create the execution plan. Why SQL Server uses statistics? That is to create best possible execution plan within a short period of time. Not the absolutely best execution plan, but best possible execution plan. When it uses estimates at query optimization stage, how SQL Server uses estimates, we will go through that in detail. So Cardinality Estimator will answer these type of questions. How many rows will satisfy a single filter predicate or multiple filter predicates? How many rows will satisfy a join predicate? You have joins in your queries, like inner join, outer join, things like that. Or how many distinct values do we expect from a specific column, or maybe set of columns? So major factor in deciding which physical operator and plan shapes. The Cardinality Estimator component actually uses the density vector and the histogram information for calculating estimates. So we will see that in our demos. So there are several database options that you can actually control the behavior of statistics, like auto create statistics. By default it's true. Auto update statistics, by default it's true. When it hit a certain threshold, when you do certain data manipulations of a table, then it will automatically kick off auto update statistics. And also you can mention that auto update statistics happens asynchronously or synchronously. So by default it is false, which means the auto update statistics happen synchronously if the statistics are out of date. So I'm going to flip over to my first demo. The first one. So here I'm using SQL Server 2016 SP1, and I'm using AdventureWorks 2016 CTP3 database as my sample database. I hope everyone can see this screen. And I'm going to create a table, a temporary table, by using existing table called sales detail. And I'm going to check the statistics on this newly created table. Obviously can't be any statistics or indexes because it just created no indexes at all. So we call it's a heap. So I'm going to execute this execution, the small query, by enabling this execution plan, actual execution plan. It has a single predicate, product ID equal 986, some value is hard coded. Okay, I need to enable the execution plan. So you can see it's a table scan, right? And also you can see here the estimated number of records, estimated number of rows, like 204.7. So how, now earlier we have seen there were no statistics. Now let's see again. So one statistics has created. So this is automatically created the statistics by the optimizer for the product ID column. And if you want to look inside this statistics object, you can copy that statistics here and use dbcc show statistics command and execute this. Here you can see actually 3 parts 6 object, and the value I have used for this query is 986. And if you look for that value, so range high key is basically the product ID which this statistics is created. So I'm going to go through it and find that value. I'm sorry. Find that value here, 986, and you can see the equal number of rows here. Equal number of rows column for 986 is basically 204.76, which is actually the estimated number of rows given by this query for the table scan. So SQL Server Query Optimizer uses histogram details to calculate the estimated number of rows at this time. And there are several ways that you can view this statistics object by using dbcc command. You can actually, if you want to just look at only the stat header, you can have a keyword called stat header. So it will give you only the stat header information. So also you can see only the density vector histogram, which I'm not going to execute right now. And also you can join stat header and density vector together and view that information as well. So just to give you some idea of how the various ways that you can see the statistics object. So now what I'm going to do is I'm going to create a clustered index for that table, and it's created. If I check the details again for statistics, again this table, you can see the non-clustered index is created. And automatically behind the scene, it creates the statistics object also for that index. So in this case, I'm going to drop the earlier case stats, the automatically created stats. Okay, right. I'm going to create an unclustered index here for the product ID column. So let's check the stats again for this table. Now you should see 2 stats. One is for product ID, which is an index actually. And then I'm going to use the same the query.
Susantha, we lost your audio. Hello, Susantha. Right, we lost your audio.
Can you hear me now?
Yes, I can.
Hello?
It's great. Yes.
Ah, okay. Sorry, something has happened. I don't know. Okay, I'm continuing with the presentation.
Yes. The screen's fine.
Okay. So if I look at this histogram for the this index which I created namely, and look for that number again 986, and you can see 195, which is the estimated number of rows for the execution plan. So basically, if you give a value, the predicate like this, it uses the histogram to identify that, locate that value, and get the estimated number of rows, calculate the estimated number of rows. In this case, my number is different, 839. So 839, it gives you some result for 47 records. And if I look at this statistics object again, and if I check the value 839 here, I don't find the exact 839 value, but it's somewhere between 836 and 838, which is the boundary value for the range high key. And between these two, it says the equal number is 201. Between these steps, 839 is 838 and 843. And you can see average number of rows is 103.5. And if you execute it again here in the execution plan, if you have your mouse pointer to index 6, you can see 103.5 is the estimated number of rows. But this time there's a slightly difference because the index, the product ID value does not directly there in the histogram, but it's between in two steps. So in 8399 843, and if you execute these three queries, which is 840, 841 and 842, which actually falls within the same step, and if you execute all these three, and you can see actually the first query returns 0 records, and the second one returns 160 records, third one again 0. But if you look at the execution plan, the first one estimated number of rows is 103.5. The second one 103.5. Third one is also 103.5, which means in all these three cases the estimated number of rows is same, whereas actual number of rows is different, because it uses the histogram again, but it's not a direct hit. I mean, it's not a exact matching for the histogram, but it's between two steps for these 840, 841 and 842. But between these two steps, average number of records is 103.5. That's why it's given 103.5. So I'm going to give you another example. Let's say if you use a variable instead of the value directly in the where clause. So 859 is assigned to a variable called product ID, and product ID is used here.
And if I execute this execution plan, and you can see estimated number of rows as 456 point something. And let's see how SQL Server Optimizer decided that figure. And again, this is product ID column. It's again the product ID column. So I'm going to use this time density vector. You can see the product ID column density vector is this figure. And also, if you just check what is the sample records to create this statistics is this much. And in this case, the density figure of the product ID is going to multiply by the number of rows of the table, which is actually the sample rows sampled. If you execute this one, you will see 456, that same figure that we showed earlier. So in this case, what happens was 859 is not directly included in the where clause, so that at the optimization stage, it doesn't see this value. So it has to calculate some generic value because it uses this variable. That's why the estimated number of rows is different at this time. Okay. Let's flip over to our slide deck now. So that demo, I wanted to give you some idea about how SQL Server actually calculates the estimated number of rows. There are various cases that we can look at here, but we don't have time for all these cases. But I have given a few examples of how SQL Server uses histogram and the statistics to calculate the estimated number of rows. So the why the accurate cardinality estimates is really important, because it ultimately decides how much memory and what is the access method and what are